Hot chocolate, Azure, Cosmos, Entity Framework, Power Tools, Netology Suite,
Countdown commencing. T-minus 2 minutes.
Jeremy Lickness,
Shay Rojansky,
Chris Lanson,
Arthur Vickers.
.net data. T-minus 1 minute. Thirty seconds. Ten, 9, 8, 7, 6, 5, 4, 3, 2, 1. Liftoff. We are go for .net Data Community Stand-Up.
Awesome. Hello, everybody. We are live again. We have Shay. Actually, you were there last month as well, right? But before, you are muted, but still fine. But before, you ditched me a couple of times, so...
Hey, don't be like that. I'm here now. That's what counts.
Okay, awesome. So what's new? What's new in efcore? Do you remember what the preview currently is?
We're just right now we're at preview 4, and we're locking down preview 5, which means it will get released in a few weeks.
Correct.
We are doing quite a bit of work on stuff like JSON indexes that might not land in time for preview 5. Andre is working on that quite furiously, so that you can index columns inside JSON in SQL Server, etc., and stuff like this. What else have we been doing? I actually have don't have the list right now in my head. I would have to look.
Let me go through the list for preview 4 because that's what matters for the people because they can try it.
Indeed, that makes sense.
The biggest feature in preview 4 probably is the approximate search for SQL Server. So that's big one. If you are doing some vector search on SQL Server, definitely give it a try. You can do .vector search with approximate, and it will use the proper functions, proper syntax, and it will be translated. Yes, I know what you want to say. Say it.
What do I want to say?
The with approximate and top.
No.
No?
No, all I wanted to say is this goes together with vector index support for the first time. So SQL Server vector indexes are now supported. All this is still preview on the SQL Server side, but we're supporting it in EF already. That's like we're kind of making sure to expose all of that stuff, and that goes very well together with some full text search improvements that we did earlier in this release. This is in the previous preview, so we gave a lot of love to full text search in SQL Server because it's frequently something that you want to use together with vector search. The two really work well together. We usually call this hybrid search. And on that note, I can give you guys an upcoming thing as well. We just merged for .NET. This is not just EF. We merged a new full outer join operator to link. So just like you've got an inner join, a left join, and a right join, we will now have .NET 11 will have a full outer join where you can take two sets and do a join, even if on both sides some of the things are missing. That's not a formal definition of what a full outer join is, but you guys get it. And one thing that we will do probably for Preview 6 is add support for this in EF6 so that you can mix vector search and full text search together. So there's a whole nice kind of composite feature coming to your way.
Yeah, the next one is that if you have the temporal period properties, you can map them now to properties on your .NET classes and types. We have more translations for datetime offset. So if you have like year and time of day and stuff like that, it will get translated correctly. Bunch of improvements on .NET EF. So if you have .NET EF, .NET-EF.json, you can have the defaults in there. So you don't have to specify them all the time and stuff like that. And we have a couple of breaking changes that you can get in the preview docs, and definitely will be part of the breaking changes together on the website, because we will have more breaking changes and stuff like that in there. So this is basically the biggest features in preview 4. If you're interested in having the full overview of what happened, you can go into the release notes and check the document in there. And with that, we have one important thing to say. The build, Microsoft build, is close. It's June 2nd to June 3rd. So if you're interested in that, you should definitely check the website, build.microsoft.com, and register, stuff like that. Check the sessions, the schedule, and just enjoy all the new features, all the new announcement that will happen during the build. Registration is open, probably still, and you can see everything that you need to see from the build. With that, I think we are done with this like boring stuff. Let's bring in our friend Woody. He's been on the show a couple of times, and he will tell us today a couple of common mistakes people do with entity framework queries and how to fix them. So Woody, do you care to introduce yourself?
Thanks. Yeah, so Chris Woodruff, everyone calls me Woody, all my friends, and everyone's my friend, so everyone can call me Woody. So I'm here in Grand Rapids, Michigan. So thanks guys for having me on. And yeah, I'm just an old guy in the .NET community that likes to talk about efcore. Actually, I have a talk next week on efcore at Update Krakow, if anyone is going to be there at that conference next week. But yeah, that's a little bit about me. I mean, let's talk about efcore and data more than me, okay?
Yeah.
Absolutely. efcore is what we're here to discuss.
Yep.
So where do you guys want to start?
It's up to you. I will be checking the chat and stuff like that, and you can
Okay.
demo
Okay.
based on your priority.
Sure. We can. I thought this could just be a conversation between the three of us. So, sure. I mean, I don't really have. Actually, I have to admit, I don't really have slides or anything. So I thought this could just be a discussion and talk about stuff. And I have to admit also that when you guys hit me up about a week ago, I forgot all about my old blog post that I did like last year on this. So I created a whole new 8 anti-patterns. So I think I'll do the newest one, because I think those are a little more they're a little more relevant, a little better for today. So we'll start.
Sure.
So let's talk about the first one. The first one's a low hanging fruit, but you know, I think I've done it before, and I think a lot of people that are new to .NET and efcore do this. It's the M+1 query. So it's this idea that I get something back, and so I say I get a bunch of orders back, and I'm going to loop through using C#. I'm going to do a for each loop, and I'm going to loop through each one of those and do something with it. Say like lazy load, or write something or work with that in some way. And what you have to remember is you're lazy loading, and you're going back, and sometimes you're going back across the wire to do a lot of that work. So you're getting one query to get the master list, but then to get details. So say you want to get orders, and then you want to get the I don't know, the number of items in each order, and you want to get those the items in that order. Each time you loop through your for each loop, you're calling SQL Server again. So the solution is, and I'm not showing it on the screen, but you need to use include. So use include in your SQL link statement, in your link. So you would probably say like, and I'm looking at something. So I would say like var orders equals await, and then you want to say like orders, and then dot include items, and then whatever else you need to do. So by using include, which has been around for a while in efcore, that will bring in the items for the orders in the same result set coming back from SQL Server, which is a lot more. It's a lot more. Help me out, guys. It's a little more efficient. It's more efficient.
It's dramatically more efficient. I would even say, like, I would go all out. I think that it's a great first anti-pattern. Like, it's one of the worst things that you can do is N+1. I think, like, in many cases.
Yeah,
especially because when you are testing your application locally, first of all, the local host is like super fast, and you usually have like 10 rows or something like that. Then you
it
go
looks
to the
great,
production.
right?
Exactly.
It looks amazing.
Production, you have web server and you have the database server that are completely different. Suddenly it's not more or less 0 milliseconds. Now it's 1 or 2 milliseconds. And instead of 10 rows, you have like 200. And the application goes completely down because it takes a couple of seconds to load the page, something like that.
That's correct. And if your application is going to have many users, and those queries are going to happen a lot
for each user
base, that's even a bigger impact where when you're testing is just one user, like you said, using a local. So that is anti-pattern 1. So anti-pattern 2 also uses include. Yeah, go ahead.
Can I say a word about this? Just because this is an awesome one. First of all, developers tend to many times get, look at benchmarks and get obsessed with, millisecond, like sub-millisecond changes, and you profile or you benchmark your thing. And we think about, like, we read Stephen Tope's blog post about the reduction of 20% of allocations on some call, and those are obviously amazing and very impactful things. But people should understand that these runtime changes where you're cutting off some allocations or you're using vectorization, like processor vectorization to, to speed up some function, these are absolutely negligible compared to something like this kind of thing where you're doing extra round trips to the database. This is like a whole different order of magnitude compared to these small scale optimizations, to the extent that I would tell you, forget about everything in terms of, optimizing your code and writing good C# and using spans and all that stuff. All that stuff is worth absolutely nothing. Yes. If at the end of the day, you're going to be doing an N+1, right? N+1, it's particularly devastating because it's a latency sensitive anti-pattern. The farther away you're from your database, let's say you're in the cloud, your database is already not right next to you, it's not on your local host on the same machine. The moment you start having latency, that kind of makes it compounds, it makes it much, much, much worse. And we've seen, like, this is a very, very classical kind of thing. By the way, this is not even just, if you guys look, this is not even just an efcore thing. This is a general database programming thing. So if you go to other languages, right, you go to Python, you go to Java, you can make the exact same mistake. And it's the main reason why in general in efcore, if you look at our docs, we will say that we explicitly discourage using lazy loading. So we develop lazy loading. There are reasons, like some people really think lazy loading is an amazing idea. I think it was more popular, I don't know, a certain amount of time ago. Nowadays, it's maybe a bit less. But one of the main problems is that lazy loading tends to promote N+1 because it hides. It makes it kind of difficult to see when you look at code. You don't see what will actually cause a network round trip in a query and what will not, right? It kind of, lazy loading obscures basically what's happening with your networking, and that's generally what you don't want to do in programming. You don't want to obscure heavy operations. You want to actually make them very explicit, and so on and so forth, right? So my recommendation would say, in general, don't use lazy loading. Like, I'm going to say this in a very forceful way. Of course, it's okay if you are using lazy loading, fine, use it, but then be extra careful auditing your code to make sure that you're not doing N+1. And it's basically about, Woody just said it before, it's basically when you're going to do a query and you're going to, you need both the blogs and the posts, stop for a second. If you already know when you query for the blogs that you're also going to need the posts, if you already know this ahead of time, then also fetch them ahead of time rather than later. That's basically the advice here, right?
And we'll talk about that same kind of idiom in another anti-pattern, because there's a step further on that, but we'll talk about that in a couple anti-patterns coming up.
Awesome.
So in the first one, I talked about using .include. Well, sometimes if you overuse include, you can get yourself in trouble also. And so for anti-pattern 2, we're going to talk about Cartesian explosions. So Cartesian explosions is where you have, for this, say I am getting my orders, and then I'm getting my items, my line items for every order. And then I want to also get something that is not related to line orders. Say I want to get maybe the shipping details or something else that has multiple records to go with it. Say I want to get the events. So I store all the events to do with this order, like when the order happened, when it was fulfilled, when it was shipped, when it was delivered. And so I'm getting back these orders. And if I'm just saying .include the line items and .include the events, that can lead to what we call a Cartesian explosion, where you get maybe not 10 lines, but 100 lines. Because of that, the way that SQL Server handles that, it would be better if that was split into 2 queries, and you would get your orders with your item numbers, and you would get your orders and then your events. Well, in efcore, we do have the ability to do that. It's called as split query. And that will allow you to not have this Cartesian explosion and return a lot more data in the return payload. So with the first anti-pattern, we want that associated data to come over in the return payload, but we don't want it to be inefficient in the way that it returns. So by using as split query, we will get 2 queries, and then efcore will bring those together and give you what when things get hydrated back into your entity classes, things will look what you were expecting originally. So yeah, and so let's talk about that first, and I've got a follow up with that. So anyone want to? I'm sure Shay has something he wants to say about that. So
I always have something I want to say.
I know you do.
That doesn't mean anything. No, I'm just kidding. First, I love your choices. Up to now, these are definitely the most horrible things. Like, and I think I would pick exactly these 2 things to start with as well, by the way. So again, what I like about this is that this Cartesian explosion problem is once again not specific to efcore. It's a general database programming thing. If you're doing any sort of, you're doing database programming in Python or Rust, you're going to have the same, you have to deal with the exact same problem. So this is a very general lesson we're talking about here. And it has to do with how SQL or relational databases work. That's just the way they work. When you include an efcore, we translate that by default to join, and then joins for collections. I mean, that's maybe an important thing to say. There's one-to-one joins, and then there's one-to-many joins. One-to-one joins are fine. There's no problem with one-to-one joins. And in fact, if you do as split query, we don't split them, the one-to-one joins. That's a little detail maybe that not many people know, because there's no real reason to do it. The problem is one-to-many. And in one-to-many joins, like even there, there's like two cases here. The really, really, really bad case is when you have, let's say, a customer, and you are including 2 collections at the same level, as opposed to when they're nested to each other. You can take this as homework for home if you want to think about why that's worse. But if you have you have a customer and they have both orders and addresses, and you include both of these, then you will be multiplying each order by all the addresses and vice versa. So you get a really, really large result set. And that's just how databases work. It's not even SQL Server. Postgres is the same, SQLite is the same, and so on.
MySQL is the same way. Yep.
MySQL. All relational SQL databases work the same. It's part of the SQL standard. That's how join works. That's by definition the thing. The only question that I think is maybe worth saying to give this a tiny bit more depth is, if it's so bad, then why do we do that by default? Like, why don't we split queries? Why isn't as split query kind of the default, right? If it's that bad.
Go ahead.
Do you want me to go?
Yeah. Well, I that is what my follow-up had to do with. We can turn that on by default if we want to. Yeah.
Right. But then why? That's true. Yeah, that's absolutely true. So you can do this.
I would love to know why it's single query by default. Yeah.
Very good question. So just before that, like, as you said, you can do this on a per query basis. You can take a specific query and say as split query, and all collection includes in that query will be split rather than joined. Or you can, at your context options level, you can basically say, not really, there's a global option where you can basically say, yes, all of my, implicitly everything should be, and then you can still use as single query to opt back into joins.
Exactly.
So why not always just do split query is the question here, right? And there's one main good answer here. There's several answers. The thing is, that databases, when you issue multiple queries, you have to think about the consistency issue of those different queries, right? Databases are about consistency. They're about transactions, right? And if you do a single query, then the database generally guarantees that the query is going to be consistent within itself, right? Otherwise, you just get back a mess of data. But the moment you do 2 queries, maybe the first one, gives you a snapshot of all the blocks. And then before the second query runs, somebody updated things in the database, and now you're getting something that's out of sync. So your blogs and your posts, which you got in 2 separate queries, are not in sync anymore. And that's a pretty severe consistency problem. It can cause real serious bugs in concurrent environments, which once again, you will not discover while testing, because while testing, there are no concurrent updates. It's a production only problem, the worst kind of problem. So then what's the mitigation for this? You can, if you choose, databases have very good tools for dealing with this. Databases have transactions which have isolation levels. Not so many people, surprisingly few people know about SQL isolation levels with any depth. By default, we use databases do something called read committed, which only says that a query will only show you stuff that's committed. But it doesn't protect you if you have 2 queries and something happens in the middle, then the second query might give you a different snapshot of the database. But you can go up to a higher isolation level, serializable, which means that the entire transaction will behave on, let's say, as if it's on a single snapshot of the database. And that's safe. That makes everything safe. But it also makes the transaction much more expensive. It could mean that the transaction is now holding locks. The transaction could also fail. There's a whole thing there. So we also could not opt you in by default into serializable isolation level without you telling us that this is what you want, because that impacts database performance. So I remember these discussions, like what should we do here? We had very, very hefty discussions around this. And our end conclusion was that we can't safely just say split, because then users have consistency issues. We cannot mitigate this by doing serializable, because that imposes all kinds of consequences which users might not want. And in general, when people do includes, the universal way is still to do joins. That's kind of like the expectation that users have. So we'll do that by default. It's safe. It might be problematic for perf, but at least you'll know about it pretty quickly if it is problematic for perf. So yeah, it's one of those situations. I'm sorry, I'm talking so long, but it's one of these situations. It's one of those situations with databases where there is no right perfect solution. There's no one solution that you can say, we'll do this and this fits everybody. Like, I'd love to have a solution here, but each decision we'd make has a serious downside for somebody, and we have no choice but to pick one.
Yeah. So I was just going to bring up, if you do decide you want to have a split by default, you don't need to add that, but you would have to say, if you wanted to go back to a single query, you would say add single query, and so awesome. But that's the thing with relational databases. They are complex beasts.
Yes.
That have lots of information that most developers sadly don't know much about. So
absolutely.
And I don't know everything. So
nobody knows it all. Like, absolutely. It's a question of what you've had experience with. I'll add one small note. Sure. This is a clear drawback of the relational model here. This thing where you represent collections via foreign key constraints, right? Now you have 2 tables and you have a foreign key constraint, and it's a one-to-many. And that means that you join and then you get the Cartesian explosion. If you model your data via document semantics, so if you think about this more as a JSON document, either you're using JSON inside SQL Server or Postgres, or maybe you're using something like Mongo, the problem disappears. It goes away because you have a document, you've got your customer, and then under that is a JSON list of orders and another JSON list of addresses, and you can get the entire document in one go, and it's hyper efficient. So this is one place where the document way of modeling your world is much better than the relational way of doing it. And I would really advise, like, people nowadays, we're now in 2026, right? It's not just about relational tables anymore. Like, you can do many things, including in SQL Server and in Postgres. When you're modeling your data, think about how you're going to be querying for it. If you're going to be doing a lot of these sorts of collection-y things and you want to load the whole customer as one block, consider doing, going in the JSON direction and doing it more like a document. It's a modeling question. It's a complicated question.
Yeah, it's an architecture discussion. So exactly. Okay, so let's go on to anti-pattern 3, And, I used to do this a lot. And I think a lot of people did a lot in the early days of Entity Framework with .NET Framework, where queries before EF would do a lot of server-side work. We would get result sets being brought back to our application, and then we would filter. We would work on those to sort and filter and do things. But now that is all in the past, and we have the ability to do I'll say almost everything on the relational database side. But the problem is that when you, in your link statement, if you have some type of .NET C# method that you are including in your link statement to say, like, maybe checking to see if something is active, or checking to see if a price is above or below a certain amount. By doing that, you are taking the power away from, and guys, if I'm not saying it right, please correct me, but in my opinion, you're kind of taking the power away from Entity Framework Core, and you're not letting it do its job. And that way, that result set has to come entirely back to the client, and you have, and then .NET has to, or Link has to work on that to get the result set that you really wanted in the first place.
Yeah, we call it client-side evaluation, basically.
Yes.
It's not universal, but in some instances this happens. I mean, Shay probably wants to talk about it.
Do you wanna take this one?
I see it on your face, so it's fine.
I'm always gonna want to talk. Please go ahead.
No, I'm fine.
Okay. This is a complicated history here. The good news is that for the past several releases, we no longer do client eval where we almost never do client eval where it might hurt you. The story is that efcore before 3.0 used to automatically switch to client eval the moment it saw something that it couldn't translate. That's basically what he just said. Let's say you have a where in your link, and inside is something that we see that we can't translate it. efcore 2 would basically say, oh, okay, so I can't translate this to SQL, to a where clause, so we'll just get all the rows from the database, all of the rows from the database, and we'll just apply the function locally. And in fact, one of the stories is, if I'm not mistaken, at some point that this specific thing brought down Stack Overflow, like this very, very specific mistake. Because once again, like all of the other bugs we're discussing here, you discover this only in production. So it looks great, it works fine on your limited test data set, and then the moment you do this on a table that's like whatever 10 million rows, you're dead. You're dead. You're done. But the good news is this is ancient history by now. And since efcore 3, if you try to do this, we will fail the query immediately. We will say, sorry, we cannot execute this query because it has something untranslatable in it. So we force you basically to put only stuff that can be translated into SQL, with one exception, more or less. You can do stuff that you can do client evaluation, but only in the last select. So at the end of your query, you can add a select that projects stuff out of the database, out of the SQL query. At that point, you can project out and use client evaluation, because that doesn't lead to us fetching any more information. That's basically the point. So client evaluation inside where is devastating. Client evaluation inside select is fine. That's basically the idea, right?
Only the top level select.
Yes, yeah, exactly. This is a bit trickier than it should be, Jiri, unfortunately, in our current architecture. So there are certain cases where if you put a select even before, it will move to the end and get a client evaluated. That should not be the case. But anyway, we will never do this in a case where this causes us to bring in more rows from the database. That's the important part. So this was, it's a good, by the way, example. I love these stories where we made a mistake originally. We made a big design mistake here, and then we fixed it in efcore 3. And today you are protected, and this very specific anti-pattern can no longer happen to you.
Good.
It's very important.
Good. Awesome. So we'll get into anti-pattern 4. So this is called overfetched columns. So I call it working with projection. So you know what? We've all been taught that never do a select star from a table. But as developers, .NET developers, we don't think in terms of that also. And there's reasons because of that, and I'll kind of explain it. But here's the problem. If I have a table, and say a table has Shai's been talking about JSON a lot. So say it has a JSON, a column that holds JSON, or maybe it has a column that just, maybe it's a column for a blog post, and it has an nvarchar max column. So that can go up to thousands and thousands of characters. And say you do have thousands of characters in that record for that column. By pulling back that post, in general, you are basically doing a select star from post and bringing everything back from those records. So the best thing to do is to do, when you do your select, do a projection in your link statement to only return back the columns that you need. But remember, in efcore, when you bring that result set back, you have to have a matching entity type. And Shay may correct me on this, but you do have to have or you could have an anonymous type, I guess. You could have an anonymous type to return it back into. So just remember to make sure that what you're bringing that result back into that's using projection can hold the data and doesn't cause an exception to be thrown. So and I use this is a big anti-pattern for me, especially if I'm doing mobile development. So if I have a mobile app or some type of device that has a small or doesn't have a wide pipe getting back to the internet. So say maybe it's an edge, an IoT edge device, or something that has a slower bandwidth for getting data. I always look at doing projection, so I'm not overfetching those columns that are huge and will affect my return payload. So up to you guys, what you guys want to say.
Absolutely. Overfetching is one of the big problems, 100%. Whether it matters in your specific app, like you said, Woody, that depends, right? Like if you're on a mobile app and so on, then that's definitely going to be more important, or any sort of place where bandwidth is more restricted, let's say. But it's always a good idea to only fetch what you're actually going to need. That's basically the key here. There's one thing I do want to say. So yeah, the very standard thing to do in Link and in EF is to project out to anonymous types. Basically, you do select at the end of your query, and then you do new, open your curlies, and then you get exactly the fields you want, and then you pick and choose. In fact, I love Link, but I think one of Link's drawbacks is that Link promotes overfetching, because by default, if you don't add that select, then you're getting everything. So it's a get everything by default sort of thing, right? Link. Whereas it would have been better. the reason for this is that link is originally also a link for objects. It's in memory. It's linked to over memory where there is no fetching, so you don't really care. You just have the objects that you want. But as a language used to express queries that get executed remotely, it's maybe not the best thing in that sense, right? Because it kind of forces you to have to opt into and to constantly think about what you want to project. If you look at, for example, if you look at like a language like GraphQL, preventing overfetching is part of the design of the language. So you actually have to say what you want, like always. You can't just say there is no star in GraphQL if you look at it. Like you don't have that option basically, right? So it would have been better also if Link kind of forced you to think about this question. But I do have, there's one note that must be said.
Sure.
About why not always do this. It's a bit like before. So why not always do this? And the reason is, if you want to use change tracking, let's say you want to load the blog, make a change, and then cause save changes, then you can't do this because change tracking only works when you load the entity out of the database. So you have to project out the blog as it is, which means getting all of its properties. And then only then you have this nice machinery of changing something in .NET, the properties on that entity, and then calling save changes to have EF persisted back. You can still, like, if you're perf-minded though, I would still encourage you to, I would still tell you, get that anonymous type, and then you can use execute update or execute delete, these other APIs instead of save changes, the non-change tracking update APIs. You can still use those things to say exactly what you want to change. But that's a more manual sort of style of programming, right? You get exactly the fields you want, and then you tell EF exactly which fields to change to exactly which values. It's a lower level way of thinking about database programming, right? But that's the efficient way. That's basically the efficient way.
Yeah, and as me as a API, I do a lot of minimal API and web API development, and so projection for me is easy because I don't need change tracking, and I turn all that off. Okay, so I see we got to get through some few.
Shutting up.
No, I love your insights, Shay. So the last add time pattern talked about columns and not doing columns. Now let's pivot, and talk about only returning the number of rows that you really need. And so the next add type pattern is when we don't add pagination to our applications. So imagine you're you're developing an application, and I'm going to use orders again, and you're saying I need all the orders for a certain store. So you have a bunch of brick and mortar stores. I want the orders for the New York City store. Well, that could be hundreds of thousands of records, and you're going to bring it into your ASP.NET Razor Pages application, and all anyone's going to see is 20 rows at any one time, because that's what your table's set up for. So many developers will return the whole thing, even though their tables are set up for pagination, but they don't set up link and efcore for pagination. So this is where you need to understand take and skip in the link language. So say I want the first page of my, I never get just one page. I usually get 3 pages at once. So if I'm going to get 3 pages initially, I'm going to say, and it's 20 rows per visible page in my HTML table, I will say skip 0. So skip 0 just means you're going to start at the top of your result set, and I'm going to take 60. So I'm going to take 60 rows in this result set. And then when I need the next set of data, I will say skip 60, take 60. So I'm always taking the same number, which for me is 3 pages, but I'm skipping the page size. So it would be 0, then 60, then 120, then 180, and on and on and on. And so that will also help out with the performance and the efficiency of your application, whatever application. And this also relates to all databases and all ORMs or data fetching. It's not just efcore. Always think about pagination in your application. So I'll let you guys give your take.
Very good point. I've got two things to say about this. So much like before, so there's a really nice comment I like here by DZVer999. A good SQL programmer always adds limit to the queries. I 100% sign that. Like there should be. In fact, I consider it almost a flaw in the language in SQL. The fact that that by default, once again, unless you explicitly give a limit, you get all the rows and I would have rather had SQL force you to use a limit, and if you really want all the rows, then you put some limit all or something like that. Like I would have preferred if the language forced us to think about this because of all the reasons you just said.
That is a good question. So I'm going to ask you: is there a global setting when I set up my DB context? Is there a global setting for query limit?
No.
Has
So
it been
I was
discussed?
not really. Like
Okay.
I would first think about this. I would love this to be in SQL itself, but that obviously is not happening, and we have no say over this. One could think about it as an efcore feature. 100%. Like nobody's asked this because it's not typically the kind of thing that somebody asks for. It's more a thing that we think about. Like I think it's a great idea. I think we should open an issue for the backlog and allow people to opt in to us forcing them to specify a limit. I think that's
I'll create it so I can have
I love it.
I can say I actually added something for efcore. So
I love it.
I want to be stingy. I want to be okay.
However, I do have one thing I want to say about the style of pagination. That's an important point. So you just described using skip and take, which is what most people do, and this is the classical way to do pagination. I do encourage people. So there's the link that's posted here down below. I really like in our docs. I encourage people to go and read that thing. In 2 words, basically using skip or offset for pagination is a bit of an anti-pattern in itself. Like a little bit. Basically, when you do,
I love that. I'm getting some good insight.
But it's not like N+1. It's a thing that few people know, and I'm very happy to have an opportunity to talk about it. The problem with skip and take or offset and limit in standard SQL is that when you do a query and you say offset 1, then the database actually has to go and skip the first row, but it still has to calculate it and go over it. So if you now, as you're paginating and you get further ahead in the result set, that skip costs more and more and more and more. And if you do skip over 1 million rows, that's actually a huge amount of performance that you're losing by doing skip. So now, not everybody is going to develop apps that have pagination for 1 million, elements. But if you are dealing with very big, very large result sets and pagination, then instead of doing pagination via skip, you should be doing something called key set pagination, which in 1 word is basically use the where clause instead of the skip clause or the offset clause. And what that means is basically let's say you order by the ID, right? You're paginating. Instead of skipping the first 100 elements, simply remember what is the last ID that you showed the user. And then your next query should be, give me all the rows after that ID and limit that to 10. And once you do this, the where clause obviously is very, very well optimized for indexing. So the database will very efficiently use the index to go precisely to the row that needs to be shown to the user.
And then work from there. Okay.
And then work from there.
So I'm going to be updating all my talks that have pagination to use that. So
key set pagination. Like take a look at the docs there. Like it used to be one of my crusades. Like a couple of years ago, I was very excited about this, and everybody who listened, I said, convert all your offsets to where clauses, because when you're paginating, it's more complicated than this, but it's definitely it's an important piece.
Thank you, Shay. That is good. So
also one thing.
Yeah, go ahead.
Take an offset, and that's that you can mess or even
Yeah.
show some records multiple times if
Absolutely.
update happens on the database side. And then some people are confused, like, why am seeing this record twice, or why I'm missing this one, because hey, I know it's there. It's like order that happened.
And that's where if you have updates and and people are updating the
Exactly.
then that's going to throw off your skip.
But not your where. That's another advantage.
But not the where, because those new records, even though they may show up because of the where clause earlier, they won't because of the
won't
index.
show. Exactly. So the other advantage, which thank you very much, Jiri, for bringing it up, it's not just more efficient, it's also better in the face of concurrent updates.
Exactly.
It's more bulletproof pagination that will not miss rows, and it will not duplicate rows in the pagination interface.
So I was wrong. I love being corrected.
Absolutely not.
I love learning. No, I love learning the better ways of doing it. So, and I think our audience probably loves it too. So anti-pattern 6 is the common don't do synchronized queries, don't synchronize, use async. And this really means don't use dot result or that's a big one, dot result. Don't do a query and then say dot result, because what that is doing is that is locking up the IO thread, and that is causing your application to basically wait for that whole result set to come back. Use and we have great async capabilities in .NET. So just know that. So the fix could be doing a two list async, and that is a much better way to use asynchronous programming. But remember, you have to async the method, and you have to await the query. So just remember that. So that's just basically telling developers that async is very, very important with querying the database, because we don't want to just sit there and wait for that query to come back, which during testing isn't going to be exposed because you're the only user, and usually the database is on your local machine. So it's not going to surface so much until it gets out to production, in my opinion.
In fact, I don't know whether it was in 9 or 10, we removed support for synchronous, basically, operations in the Cosmos provider.
Oh, good.
So you cannot execute synchronous operations. We removed it from the tests and everything. Everything for Cosmos needs to be asynchronous. Otherwise, we throw an exception or something like that.
Yeah. Is there any thought of doing that for SQL Server?
So the important thing here is that the Cosmos SDK, the low-level Cosmos thing, actually doesn't support sync operations. In fact, most modern things, by the way, all new things in .NET, all new APIs getting introduced, everything basically is async only. Sync is basically sort of dead. I'm saying this very forcefully. I may be exaggerating. I'm pushing the point a bit too hard, but I want to double down on what Woody said. You should, at this point in 2026, only be using async in general, right? You should be avoiding all sync APIs. And if we had been designing .NET from scratch today, we would not have sync APIs at all. Specifically with the Cosmos thing, we actually made another one of those bad decisions back in the day. We said, so the Cosmos SDK is sync only, but we're going to still allow you to, so it's async only, but we're still going to allow you to do sync by doing sync over async, which is a really, really bad sort of anti-pattern. And I mean, we don't have to talk about this. It's awful.
Horrible. It makes me.
It's horrible. Exactly. So then we eventually, like, we did the breaking change of removing that and saying, okay, Cosmos only supports async. So the Cosmos EF provider will only support async because that's what we have. SQL Server is different because SQL Client, the driver does support sync and async. So it's really up to you.
Anyway. I know, but it shouldn't be done.
So I mean, I still don't think it shouldn't be our role to force people, to do stuff. But I agree with you. I agree.
But that's another that would be another efcore global setting to say, do not allow anyone to do synchronous queries.
So why stop there? We should be doing this at the level of .NET itself, maybe, right? That's even better.
Okay, well, you take that up with the .NET team. So
yeah,
awesome. Well, I know we only have about 5 minutes left, so we have 2 anti-patterns left. So the 7th is using, I'll say in here in my notes it says as no tracking on mutations. So what that really means is, so many people like the idea of as no tracking, but don't use it when you're actually going to do save changes, because it wasn't really meant for that. Or if you are going to do it, there's some hoops to jump through and stuff. So I always tell people only use as no tracking when you know that result set only needs to be read only, and you're not going to change anything on it, like in the matter of like minimal APIs and web APIs. So that there is a fix. So if you want to do it, efcore will detect the change and generate updates. But I know in efcore 10 in my notes, it says execute update async is a preferred path for bulk and targeted set-based updates. No entity loading, no change tracking. So yeah, that's a delegate-based setter. So will allow for conditional logic. But for the most part, as no tracking, leave that for your APIs and for your result sets that are just read only, and then you don't have to get into too much trouble. But I'm sure Shay will tell some
since our time is short, let's move on to the last point. I don't want to because I don't want to.
Cool. So the last one is one that I will say 80 developers don't look into. And this is the anti-pattern 8, missing index coverage. So for me, every query that I write, I go into, if it's SQL Server, I go into SQL Server and take a look at the query plan. Every single one. And I take a look at that query plan, and that query plan will tell me if indexes are missing. If an unclustered index is missing, which will totally be the case. In here in my notes, I have some stuff to do on the .NET side to say to do a fix, like in your creation of your DB context, you can say has index. You can do a .has index, which is great, and that helps. Or you can do it in your annotation on your entity class. You can say that there's an index on the table that this entity represents. But I always like to just go back to SQL Server and find where my indexes are missing. SQL Server will either tell you, or if you take a look at the execution plan, the visualization of it, and you find one of the subqueries uses like 80-90% of the total allocation for your overall query, that usually will tell you that you have some type of missing index also. So my suggestion is to be a detective, learn how SQL Server works and execution plans, and go in there and actually make sure that your queries run efficiently on SQL Server and don't have missing indexes.
That's a great point. It reminds me like the what we started with N+1. I sometimes see developers concentrating on the wrong thing, like going and hunting down allocations or micro optimizing their code while their database query is missing, an index, which is completely ridiculous, because that is so much more important than any little, optimization. So always concentrate on the right thing. I will also say it's important. So indexes also aren't free. Indexes both cost in terms of like disk space, as a user here just pointed out. They also cost, that people think about this a bit less maybe, indexes have a cost in terms of write performance. So if you're write heavy, as every time you're doing a write, then you need to update the indexes. And if you have 10 indexes on a given table because you need to do where on each and every one of the columns, you're going to be paying for that on the right side of things, right? So it's also, I would advise, it's also a matter of not always just adding indexes. You have to stop and think about modeling your database, like a good DBA and all of that stuff. It's also worth remembering that some queries are hot and others are not, like hot or not kind of thing, right? You don't want an index, and you don't want to optimize a query that's going to run once and nobody cares about. That's an analytical kind of report. Like once a day report.
Like a report that
end
gets
of day
run
report
once a week, and you don't care how long it takes.
And exactly right to write. This is why you hire a DBA.
Well, I was going to bring it up, but Wraith too. Thank you for bringing it up. There is a reason why we have database developers and DBAs and people that it's their jobs to
absolutely
to work and concentrate on that.
One of the things about EF is it makes it easy for you you're a developer. You're insulated away. You don't even need to know SQL, right? All you have to do is write link. It's wonderful. It makes it very easy for you to kind of lose touch with the actual reality of what's happening under the hood, right? And the fact that you have to think about, you do have to be able to read a query plan. You have to be able to go, and for your database, right? This is different for Postgres, for SQL Server. You have to be able, like, if you care about performance in any way, maybe you're working on something where there's no performance, fine, doesn't matter. If you care about performance in any way in a serious production app, you have to be able to look at the logs of the SQL that EF is actually producing. You have to look at the query plans produced by these queries, and you have to identify the hot queries that are worth your attention, not get lost, because there's tons of queries, not all of them matter. And you have to be able to actually, like Woody just said, look at your query plan and identify what is making it slow. If you're just missing an index, that's wonderful, obviously. Sometimes it's much worse, and you have to tweak things around and remodel like your entire thing.
Exactly.
That's much worse. If you could just fix it with an index, you're relatively, in a good position.
It comes down to, I always tell people, just because your query gets data back doesn't mean that it's efficient.
Absolutely. And that applies to almost everything that you mentioned today, by the way. That exact sentence, I love it. I love that way of saying it. Like N+1 works fine, it brings you the data. Cartesian explosion works fine, it brings you the data. All of these things will kill your app if you're doing them wrong, like if these anti-patterns. So it looks fine, it brings you the data, and it will still kill your application with any serious load. So
awesome. Well, that's all I have. So
that's awesome, because we are right on time.
Yes.
Amazing.
So thank Woody for presenting us these anti-patterns. It's always nice to have some kind of opinion. So somebody brings a list and gives us like, hey, these are the ones that I see the most and stuff like that, because obviously we see all sorts of weird usages of EF, but having like an outside perspective that you bring is always helpful, and you can see it in the chat that people are discussing different approaches and stuff like that. So it's really, really nice.
And I'm sorry I didn't bring any slides with me. So
that's fine. We don't need slides.
I think we
don't
did
need
well.
slides. Yeah,
Yeah.
yeah. I think just having good discussion. But there are lots of other anti-patterns that we could talk about too. But we could do those for another day. So
Absolutely.
awesome.
Absolutely.
Awesome. Thanks for showing us your anti-patterns, Woody. I'm pretty
you.
sure we will have you back in some time in the future. For now, that's all we have. Guys, please check the schedule and the website because we will be scheduling a new stream for next month again. And yeah, see you next time.
Is it my thing about temporal tables? Do you remember what's up next time?
I don't remember from
I'm
the
not
top of
sure.
my head, so it will be a surprise.
Okay.
I hope so.
Surprise then.
Awesome.
All right. Very cool. Bye, everybody.
Bye.